All right, so let's look at number 5. Let's see if y'all can graph this one the same way we just graphed the one on the warm-up. Make sure y'all's phones are up. Make sure they're not in your lap. All right, so again, if you've got x squared on top, I want you to factor the top. Okay, what goes in the front of each parenthesis if we're going to factor that out? It's got to be x times x, right? It's the only way you can get x squared. All right, Griffin, for this spot and this spot, they got to times together to equal 3. What can we times together and equal 3? 1 times 3. You guys are all asleep today. All right, so are my signs going to be the same or are they going to be different? Well, look, your second sign's a minus. I've got it on the board for you. When your second sign's a minus, your sign's got to be different. One's got to be a plus, one's got to be a minus. All right, well, when you add them up, it's got to equal -2. That's one way you can look at it. And also, look, x minus 3 is there. That lets you know that one's got to be a minus, that one's got to be a plus, because you know they got to match up. All right, so you mark off one off the bottom with one that matches up with it off the top. And all we're left with is x plus 1. So, graph that by rise over run. Put your dots on your graph. And then the last step is find where the hole goes. All right, so there's an understood 1. First of all, I start at 1. That's my starting point. That's my y-intercept. My slope is 1, so it's 1 over 1. Guys, it's always going to be up 1 over 1 on these problems. Put your points there, going up and going down. All right, and our last step is we got to find where the hole is. And how do we find the hole again? The hole is made from the one that you marked out. So look, we marked out x minus 3. If I move minus 3 over, that's a positive 3. So your hole is going to be at positive 3. Go over 1, 2, 3 and follow it up. There's your hole. So look, we got x times x. All right, what numbers can I times together that equal 1? Got to be 1 times 1. Now, are these signs going to be the same or are they going to be different? Look at it. They're going to be the same because this time my second sign's a plus. So look on the board. When your second sign's a plus, they got to be the same. So are they both going to be pluses or both going to be minuses?
Both of them are pluses.
Let's check. Uh-oh, the middle's a -2. That means both of them's got to be minuses. Another way you could have known they both were going to be minuses, the x minus 1 on the bottom's got to match up with one of them on top. Okay. You mark out x minus 1. Now you can only mark one on the bottom and one off the top. You can't mark them both off the top even though they're the same. So what's left over is that. Graph it. Go to -1 for your starting point. You got to rise up and run of up 1 over 1. And make your points all the way across your graph. All right, where's the hole at? Where's the hole, Luke? Good. I'll say it again. The hole comes from the one you marked out. Since we marked out x minus 1, bring it right here and you set it equal to 0. And when you move it over, doesn't that turn into positive 1? Yep. So go to positive 1 on the x-axis. There's your hole. We should start to get faster at this now. That fraction right there. That's x squared minus 16. What's the square root of 16? 4. So we got x plus 4 and x minus 4. That's how you factor it out if it's just a difference of squares.
Cancel out the left one.
Keep going, Griff. All right, now bring down the one you didn't mark out. It's the only one you got left, and that's how you're going to make your line.
Put the mark at -4. The x
Good. Good. Perfect.
Up 1 to the right 1.
All right, so the only thing left you got to explain to us is how do you know where your hole is?
I didn't get that far. I don't know.
All right, well, good. I can show you, and then you'll have it. The whole is made from the one you marked out. Since we marked out x plus 4, Griffin, you put x plus 4 equals 0. Move it over. That's going to be negative 4. So go to negative 4. There's your hole right there.
You can tell if it's going to be open or closed.
It's always open. All right, on the back it looks like what I have on the board. They want you to graph the parent graph and then graph each one of these. It's going to be pretty similar to the parent graph. So first thing let's do, you guys are supposed to know what that graph looks like if it's an x squared. Does anybody remember that from last year? All right, you're supposed to know, but if you forgot it, you can plug it in your calculator, it will do it for you. All right, everybody click the y equals button in the top left-hand corner. Everybody click y equals top left-hand corner. And we're going to type in x squared. Because we want to see what the x squared graph looks like. So if you don't have x squared on the y1, clear out what's there. All right, if you need a calculator, get you one.
Say that again, quick.
All right, y equals top left-hand corner. Got it? Clear out. If anything's there, hit clear. Now just type in x squared for me. So where's the x at? Somebody remember the x?
Right there.
Yeah, right there on the right side of that green alpha button.
Right.
X, and then the square, just hit x squared. Now all we got to do from there is hit graph. When it graphs it, what kind of shape does it make? What's that called? Y'all remember? I know it's a U, but what's the mathematical word for it? Parabola. All right, so if it's x squared, Griffin, you get that? It should make a U.
Look, mine's a big U. Yours is small.
You did something wrong. Let me see it. Or we might need to reset your graph. We got the same exact thing.
Oh, yours looks smaller from over here.
All right, so we got the same thing. So again, Griffin, if you don't know what the first one looks like, plug it in your calculator. It will show you. So for this one, the parent graph, everybody draw a U, a parabola, right in the middle of your graph. So there's no way you can miss out on the test. Just plug it in your calculator. All right, now let's do number 10. Since we have an x squared, look, we still have a squared in our problem. It's still going to look like that shape. But it's going to change it's going to change in 3 ways. So what I want y'all to do is always start in the back of the problem. If it's minus 4, would y'all guess that's up 4 or down 4? Down 4. Minus 4, it's going to go down 4. So I want y'all to write that it's going down 4. Now, if you want to write the word D-O-W-N, you can, or you can just use arrows. But do you understand, Griffin, how it's going down 4? All right. Now we look at what's inside the parentheses. If it's x plus 2 equals 0, and if you move over plus 2, what's it become? Negative 2. So would you guess it's going forward 2 or backwards 2? Backwards, because it's a negative 2. It's going backwards. So it's going left 2. If you want to write out the word left, that's great. Or you can use arrows. But you got to write down the ways that it changes. All right, last change. We got a minus right here in the front. So I want y'all to do this. Using your calculator, if you don't know what the minus does to your graph, let's type in negative x squared. And let's see how it changes what we have. So now go back to y equals, clear it out, type in negative x squared and graph. All right, what did it do, James? It said it flips. Instead of going up, it flipped, it's going down. So from now on, you shouldn't have to type it in. We know if there's a negative in front, it's going to flip it over. And the mathematical word for flip is reflection. If you flip it over, it's a reflection. All right, you guys should have done all this last year. Nope. All right, so now I showed you number 10. We're going to do 11 and 12 the same way. Oh, sorry, I forgot to graph. We got to finish number 10. We got to go down 4, left 2, put a point on your graph. Down 4, left 2. And now we got to flip it over. So instead of going up, we know it's going to be going down. Try to draw it about the same size as your first graph. All right, any question on how we do number 10? So you're going to have to write the 3 or 4 different ways that it changes up under it, and then show me the new graph. And if you want to get 3 different colors to draw each one in a different color, that's fine with me. Or you can just do them all in pencil. Griffin. Yep. Y equals negative x squared. And hit graph. Yeah, well, it should graph it for you. Let's see. Yeah.
It did it backwards.
Yeah, it did it backwards because we put a negative in front of it this time. All right, let's go to number 11. All right, start in the back, guys. Up 5 or down 5? Up 5. Write it down. Look here. Is that going to be right 3 or left 3? Right 3. Do y'all understand why it's right 3 and not left 3? We got to flip the sign anytime it's in parentheses. Last one. Whoa, we got a 1/3 in front of it. All right. So if you didn't know this on a test, you can plug it in your calculator and see what it does. I'm just going to show you. If it's got 1/3, if it's got a fraction in front of it, any fraction, it's going to do this. What happens when I press down on this paper? It gets fat. What happens if I stretch it out? It gets skinny. So a fraction makes it compress, makes it fat. We're going to write compress. If you want to write fat, it's fine with me. As long as you know what it means. Now we got to graph it. Up 5, right 3, put a point. Everybody do that on your graph. Go up 5, right 3. Now we just got to compress it. Hey, I flipped this one, number 10. Why don't I have to flip number 11? Yeah, 10 had a negative. 11 does not. So this one's got to be going up, and it's got to be really, really fat. So when you draw it on your graph, make sure it looks much fatter than the first one you drew. Anybody got a question on 11?
I'm confused how you solve it.
Ask me a question. What you got? You understand how I got up 5 and right 3?
No, that's what I don't understand.
Plus 5 on the end is up 5. That's going right 3 because whatever the sign is inside the parentheses, you got to flip it. So that makes it a positive 3, which pushes it that way. And the fraction in front makes it compress.
So what is the square going to do?
Oh, the square, you don't even have to mess with the square. It's just showing you what kind of shape it is. If it's got a square in the problem, it's going to be one of those parabolas.
Just graphing the count.
Yeah, you got to do these 3 and you got to graph. All right, so we're on 12. On 12. All right, so Griffin, we start in the back. Minus 2. All right, first of all, 12 is missing something that the other ones had. What's it missing? Parentheses. All right, so that means we get to skip the part about going right or left. Just skip it. So Griffin, you look in the back. Is that going to be going up 2 or down 2? Minus 2 means it's going down 2. Plus 2 means it's going up 2. All right, now we don't have to go right or left. Well, I got a fraction in front of it again. So what's the fraction do? It makes it compress, makes it fat. Let's write that down. And what else do we have in front of it? You got a minus. What's the minus do again? Flips it. Yeah, so you shouldn't have to plug this in your calculator. You can. And now we just got to graph it. So the first thing, let's go down 2 and put a point. All right, next thing, we got to flip it over and compress it, so I got to draw it really, really fast. All right, and 15's got something new on it. All right, any question? All right, let's go to 15. Start in the back. We got minus 1, so that's down 1. Now, is this one going to go right 2 or left 2? Right 2. All right, we got something new on this one. Now, look, we got a minus, so I know it's going to flip. But now we've got a number that's not a fraction. So, Griffin, I've had fractions before. I know when it's a fraction, it's going to make it really fat because you squish it. When it's got a number that's not a fraction, you stretch it out and it gets really skinny. It gets really thin. So let's graph this one. Down 1, right 2, put a point. All right, so now I gotta flip it and make it skinny. Now, if you'd rather write stretch right there instead of skinny or thin, that's fine, I don't care. So